All right. I'm going to be talking about square roots and cube roots, also called radicals. These are radicals when you're dealing with lengths. When you're dealing with lengths, the answers can only be positive, okay? Because distance can't be negative. So let's say you're looking for the square root of 49. Why are you looking for the square root of 49? Because the area of the square is 49 inches, okay? And we want to know what the length of each side is of that square. So you're looking for a number times itself, that makes 49. So the answer for this one is 7 times 7 will make 49. So the square root of 49 is 7. What about this one? 64. There's a 3 in this radical. Yeah, because they're asking you what number times itself again makes 64. Okay, again, we're talking about lengths. So this is probably like the volume is 64, and I want to know the length of each side. Okay, the volume of a cube, meaning all the sides are the same. So you go, okay, what number times itself again gives you 64? It's 4. Because 4 times 4 is 16. 16 times 4 is 64. So the answer for this one is 4. Okay? For this one, what's the square root of 64? Still, what number times itself makes 64? In this one, it's 8 times 8. So the answer for this one is 8. Again, when you're looking for, when do you use the square root? It's because you have the area of a square and you're looking for the side. When you're looking for a cube root, you have the volume of a cube and you're looking for the length of each side. Okay, so lengths, all the answers are positive. Now here, non-length radicals, which means we have a possibility of negative numbers. Okay, now when you're dealing with square roots, there's two different options. If what's inside of the square root or radical is a positive number, that means the answer can be positive or negative. Okay? When you're dealing with a square root and there's a negative inside, then there's no solution. Okay? For this one, for example, let's say we have 4 in there. Okay? If 4 is in there, a positive 4, then the two answers are positive 2 and negative 2. Why? Because positive 2 times positive 2 will give you 4, but negative 2 and negative 2 will also give you 4. Okay, because a number, if they have the same sign, the answer is going to be positive. Here, if you have a number and the other number is the same sign, which it has to be because you're looking for a number times itself, it will always be positive, so it will never reach the negative solution, so there's no solution for that. Next, we're talking about cube roots. Now, cube roots always have a solution. Okay? So if you have 8, the answer here is going to be 2. Okay? If it's negative 8, the answer is going to be negative 2. So this always has a solution. Always one solution. Okay? If it's positive, for square roots, it has 2 solutions. And if it's negative for square roots, it has no solution. Okay? Those are the 3 scenarios. So here, the answer for this one would be positive or negative 5. The answer for this one is no solution. The answer for this one is 3, and the answer for this one is negative 1. Okay, if you want an explanation for why these are negative 1 times negative 1, you're right, is positive 1. But you have to multiply times negative 1 again. So times negative 1 is going to give me the negative 1. Okay? All right, let's go to these exponent problems. All right, now for these, when you're multiplying these exponents, now what I don't want an answer, I want something that's equivalent to this with the same base. Okay, so I want something equivalent to this, but just with one number as its base. So here, 8 times 8 to the 2nd power times 8 to the 7th power is 8 to the 9th power. Okay? When you're dealing with the exponents are always doing one step behind from what you think you're doing. So these numbers are multiplying, right? But we're going to keep that the same. We're going to be changing the exponents. So the exponents are going to be reacting, meaning they're going to be acting a step behind. So instead of multiplying, they're just going to be adding. Now this one, the exponents are the same. So I'm going to leave the exponents the same. Okay? The thing I'm changing is the 3 and 5. The 3 and the 5 are going to actually multiply because they're numbers. They're not exponents. They're just numbers. So 3 and 5, this is going to become 15. Now I'm going to explain both of these. Now the reason for this one, so it's 8. This one is 8 times 8. So I'm going to branch this out. This is 8 times 8. Now this one is 8 times 8 times 8 times 8, 7 times. So this is multiplying. I'm bringing down the multiplying. And then I'm bringing down this one, right? 8 times 8 times 8 times 8 times 8 times 8 times 8. Okay, how many do I have? 1, 2, 3, 4, 5, 6, 7. I did it. So this is 7 eighths. So now I've expanded this so that you see it in its entirety. Okay, so this is what we're looking at up here. This is just a long way of writing it. What's another way we can write this that you're looking? 8 to the 9th. Okay, that's why. So this is the same thing as this, but just a very quick way to look at it. All right, now we're going to do this one. Now this one is 3 to the 5th power and 5 to the 5th power. So 3 times 3 times 3 times 3 times 3, then times, I brought down the multiplication, and then 5 times 5 times 5 times 5 times 5. I know they look like S's. I don't need anybody to tell me that. Okay, so, but I need to convert this into one number, something simple. So what I'm going to do, because multiplication, the order doesn't matter when you're multiplying straight across like this, so I can move any of these numbers around. I'm going to move a 3 next to a 5. So 3 times 5, so I've used this one, I used that one, right? That's 15. And I can make that happen 1, 2, 3, 4, 5 times. So I can make 3 times 5, which is 15, happen 5 times. That's up there. Now, the next one are these. Okay, so 3 to the 5th power to the 3rd power. The answer for this one is 3 to the 15th power. Okay? So why is that the answer? Because this is 3 to the 5th times 3 to the 5th times 3 to the 5th. Okay? Now because all the numbers are the same straight across when you're multiplying, you get to decide, do you want to add the exponents or multiply the bases? So 3 to the 15th is an option, but you could have also left it as 3 times 3 times 3, which is 27 to the 5th power. That also is an option, okay? But the easier way to do it is just work with the exponents. 5 times 3, 15, done. Because we're doing repeated addition here, 5 plus 5 plus 5. Repeated addition is multiplication. Again, it looks like it's doing the exponent, but in reality, it's doing multiplying when you're just dealing with the exponents. This one here. The answer for this one is 7 to the 6th power. Why? Because on the top we have 9 sevens. 7, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, 9. Okay. Divided by 7 to the 3rd power. So what's going to happen when you're dividing? They're going to cancel. 7 divided by 7, 1. 7 divided by 7, 1. 7 divided by 7, 1. Okay, so now I'm left with 1 on the bottom and 6 on the top. So 7 to the 6th power over 1, which in reality is just 7 to the 6th power. So this one the exponents are subtracting, because one step behind of dividing is subtracting. And that's it.